Welcome back to Genetics in the Paddock with Emily. I'm your host, Emily Johnston, and I'll be taking you along on my journey to learn about all things genetics in extensive livestock. Last season, we explored the foundational aspects of genetics. We discussed everything from basic genetic principles to practical applications on farm. This season, we're kicking it up a notch. Today's guest is Dr. Michael Aldridge, a research scientist from the Animal Genetics and Breeding Unit in Armidale. And we're here this season to start off with a few hot topics, sustainability and methane being a few. This is an episode I can guarantee you'll want to stick around for and one you'll enjoy. So with that, let's get into it. Welcome back to another episode of Genetics in the Paddock with Emily. Today I'm joined by a very special guest, Michael Aldridge from the Animal Genetics and Breeding Unit. So thanks so much, Michael, for sitting in today and having a chat with me. I'm really looking forward to hearing about some of the work you do and your story.
Thanks, Emily. I'm really happy to be here today.
Awesome. So how about you start with just telling me a bit about yourself? What are you doing in AGBU? What role are you currently working in? Just give us a bit of an overview.
Sure. So I've been working at AGBU now for a little under a year and came back basically to work on everything sustainability related. So there are a number of projects here at AGBU and other partners that we work with. And yeah, I mostly work on beef and sheep, and a lot of that is focused on methane at the moment.
Lovely. That sounds really interesting. And I know it's quite a hot topic at the moment, so I'm looking forward to diving into that a bit more. But where did this all start for you? Like, why agriculture? Why genetics? Take me back in time.
Sure. So I actually went to an agricultural high school in Adelaide, Urbray, and it's actually sort of a metropolitan school, but an agricultural school at the same time. And my uncle said you should join the steer club and take animals to the show. And I was like, all right. And I ended up in the goat club. And I really enjoyed my time. I was like, all right, agriculture is where I want to be. And I ended up doing my ag degree through University of Adelaide. Eventually, I was trying to work out what am I going to do when I finish uni. And one of the last subjects I had was on animal genetics. And it was the first time where I absolutely smashed it. And I was like, this is it. This is me. I want to work in genetics. Mm-hmm. And that led into a PhD on the quantitative improvement of Australian meat goats.
Okay.
And then immediately after that, I submitted my thesis, and the next day I was on a plane to the Netherlands.
Oh my gosh.
And so then I was working at the Wageningen University in research for about 6 years. And my work there, I worked on a lot of different topics, originally on like computational efficiency and just making improvements to accuracy and genomic prediction and things. And I got asked to work on a couple of animal health projects and really enjoyed my work with the vet de Haas on those. And I ended up working on some methane projects. And then I just found, this is my passion. I love this. I feel like I'm contributing to society and I'm doing the research I love as well. So that's how I got into genetics and sustainability.
That's awesome. So how long were you in the Netherlands for?
Just a little over 6 years.
Oh, wow.
Yeah.
Lovely.
Yeah.
So how are you finding being back in Australia and how we're going with our sustainability stuff? How are you finding the change and the difference?
I love it. I love being back to start with. Okay.
Yeah.
The entire time I was in the Netherlands, I was like, I miss home a little bit. Mm-hmm. And I always loved my time during my PhD at Armidale and AGBU. And I was like, if I come back to Australia, that's where I'm going to go.
Yeah.
We do things a little bit differently in Australia in sustainability compared to other countries, especially Europe, where they're much more intensive, often barn-raised cattle. Mm-hmm. So I see that they also have a little bit of a different focus and understanding of what sustainability is. So I think that actually before we go any further, we should sort of have a little just chat about what is sustainability.
I was just about to ask that. Maybe let's set the scene. So what is sustainability?
Yeah. That's a really tough question because a lot of people have a different idea about what sustainability is. And when I talk about sustainability, I'm talking about three things basically. So that's profitability, that a farm should be profitable. If it's not profitable, that farm's not going to be around. So everything that we do in genetics, sort of leads towards improving profitability for farming systems. Mm-hmm. The second one I would say is that environmental side. That's the methane, it's feed efficiency, erosion, these sorts of things. And then the third one is a little bit more hard to grasp, I think, at the moment, but that's more around fit for purpose animals, that the animals that we have are going to be productive and do the things that they do well, converting those pastures that, monogastrics can't eat and converting it into high valued protein. We want to make sure that we have those animals that are fit for that purpose, but they don't have health issues like feet or leg problems, or in the case of sheep, like fly strike sort of issues.
Yeah.
So when I talk about sustainability, I'm not just talking about methane, I'm talking about the bigger picture as well.
Okay, cool. I think that's a great way to set the scene, especially for some of the questions that I've got for you for the rest of the episode. So essentially, sustainability is a huge focus of your work. And does that mean ruminant animals are a large contributor to greenhouse gas emissions? Because that seems to be something that's like quite prominent in conversations at the moment around sustainability.
Yeah, that's a difficult question to answer, because methane is quite a difficult gas to talk about when you talk about ruminants. In that there's a number of ways that the inventory of methane can be calculated, and I guess at the moment a lot of people consider methane as a circular type of gas, in that there's pasture in the paddock, animals eat that pasture, they belch out methane, and that enters the atmosphere, and then over time that methane, while it has a 24 times impact compared to CO2, it also then gets converted into CO2 over about 10 years, and then it goes back into the pasture again and the animals eat it. So what I will say is that methane that's being produced is having an impact on climate, and anything that we can do to reduce that methane emission has an overall contribution to reducing our human-induced climate change.
Yeah, okay, that makes sense. Why is methane something we would want to reduce and create a breeding value for?
Probably two parts to that, and the first one is the obvious, that it will contribute to reducing our greenhouse gas contributions and our effect on climate change. The other one is that basically methane is a byproduct and it's a wasted potential of energy. That methane could actually be converted into protein or into energy for the animal rather than belching it out. So every time methane's produced, that's wasted grass that it's eaten, basically. So also on the sheep object and breed object side of things, on traits that we can already measure, is feed intake. So animals that eat less produce less methane, but we don't just want animals that eat less, we want animals that eat less but produce more at the same time. So more efficient animals will also have a contribution to reducing that methane yield. So less feed eaten, less methane produced, but more meat produced or more wool produced.
So effectively creating a bit more of an efficient animal.
Exactly.
I guess looking at the methane trait, and we've spoken about how heritable traits can be in previous episodes. So when we're looking at methane, how heritable is that of a trait? And is it correlated with any other traits that we should be thinking about?
Yeah, sure. I would put it into that lowly heritable range. It depends on the papers that you sort of look at, but in our preliminary estimates, it's around that 0.1 to up to 0.2 heritability. So we can make selection and we can make improvements, but it's going to be one of those difficult traits to work with. It doesn't mean that we can't make reductions. We absolutely can. It just means that progress is going to be a bit slower. As to correlations with other traits, honestly, we expect them to have unfavourable correlations with some things and favourable correlations with others. There is concern that those will be unfavourable for production traits. Yeah. We don't really know at the moment. We're collecting that data to actually give a conclusive answer to that. At the moment, we can have some hypotheses, but we can't say for sure.
Okay. And is there anything producers can do at the moment to consider reducing their methane emissions, if that's something that they're interested in or wanting to get a bit more on the forefront, or is it kind of just a bit more of a watch this space, work in progress at the moment? No,
there's absolutely things that can be done today with the traits that are already being measured.
Okay.
If we think about sheep and cattle, the majority of methane produced comes from the ewe or the cow herds. So anything that we do there to contribute to reducing methane will have an impact. And we can select for things that are indirect traits. So a large animal produces more methane. It eats more, it produces more methane. So we can select for lower mature cow weight or lower mature ewe weight, and those animals will produce less methane, and that'll have an impact on the total methane production. But then there's other things we can look at as well, and when we talk about methane yield or methane intensity. So that's the amount of methane produced per kilogram of feed or per kilogram of meat and wool production. So basically what I'm talking about there is that anything that reduces the efficiency of the system is going to reduce your methane efficiency.
Yeah.
So basically, if you have a cow or a ewe that fails to get pregnant, that animal has been producing methane for no reason. So anything we do to improve the efficiency of those animals is going to improve methane yield or methane intensity as well.
Yeah, that actually makes a lot of sense, and it's very interesting to think about it in that way, because I'm sure that's an issue a lot of producers have on property as well. So I guess like drawing back to some of the work that you did in the Netherlands, because you were there for 6 years and worked a fair bit in the sustainability sector, what sort of key takeaways did you discover over there, and do you see them being useful in Australia, particularly in the space you're working in at the moment? Is it something that you think maybe we look at them as an example, or things that we can implement straight away, or are they just two completely different systems?
Yeah, I think that there are lessons to be learned for sure, but you have to also remember that the production systems in Europe are very different to what they are in Australia, but they face some of the same challenges that we do, and that's phenotyping animals. That methane is a very difficult trait to measure, and it's very expensive. We have a very low throughput of animals through systems that can measure animals, and that's why we don't have a methane trait already, is that it's just a difficult trait. But there are a number of projects that are focusing on that at the moment.
So when you say phenotype for methane, what do you mean? Like, what's the measurement for that currently?
Yeah, sure. So that's another big difference as well, is that the Netherlands decided that it's a numbers game. Like, they just need large number of animals measured, and they went with a device called a sniffer. So basically, this is a very passive way of recording methane, and it only records methane concentration. So basically, animals enter an automated milking robot, and while that animal is being milked, there's basically a hose in front of the feed bin, and it's just continuously drawing in the air around it, and it's measuring methane concentration. And they get records on every animal in that barn 2 or 3 times a day, every day of the year. Whereas in Australia, we have, in the sheep, we use what's called portable accumulation chambers. So these are boxes that the animal fits in, it's airtight, and we measure the methane at certain points of time in that, and we can end up getting a methane rate, and you can approximate that to a measurement of methane production, so grams per day. And in beef cattle, we're looking more at using the green feed systems. So these are commercial devices that sit in the paddock or in the pen, and it often's a nice concentrate or pellet of some sort, which attracts the animal, and then it comes in and puts its head inside, and it sucks in the air and the pressure, and it knows how much methane is coming out of those animals. And you get a certain number of measurements, and you can work out what the methane production, again, grams per day of that animal is as well.
So is it almost easier to get phenotypes from intensively farmed animals than extensive?
The Australian system is very different, and not only is the Australian system different, but we've got different production systems within Australia as well. So there's the northern side where we're working with Ben Hayes and University of Queensland, where they're measuring large number of animals. And then if we look at the southern side, we're working with University of New England with Sam Clark and New South Wales DPI on measuring southern animals. And again, there's also the difference not only of trying to measure on pasture, but also in feedlots. And I would say that you can definitely see that it's easier to measure these traits in these intensive systems, because animals are just more likely to visit these passive ways of measuring methane compared to out on pasture and the extensive systems, where they really need to have a reason to come and visit these devices. And if they don't visit them, then you don't get a methane measure.
Yeah, that makes sense.
Yeah.
Actually, so I was just kind of thinking while you were saying that, is going back to the whole goat club and your goat PhD and them being ruminants as well, do you see some sort of project in the future that might involve capturing methane phenotypes for goats?
I definitely wouldn't rule it out. I can see that, there are a large number of goats in Australia, and they're all producing methane as well. So there are projects that are working on building reference populations in goats through Measure Goats, through New South Wales DPI, and I could see that value adding to that with methane would be a really good opportunity, but we'll just have to see what the future brings.
Yeah, cool, interesting. Just another thought that I had around the goat stuff as well, and because we have quite a large population of rangeland goats that are wild, do you think those phenotypes captured might be useful for something in the future to do with the wild goats?
Yeah, that's a difficult one.
Yeah.
Any improvement in that rangeland system is incredibly difficult. We would have to start at the farm side, or the more intensive side than we can. But again, I would never say never.
Yeah, interesting. Okay, awesome. Thanks for answering that. And I guess to wrap it up, I'm really curious to see, so if you had, say you had a crystal ball and you could look into the future, What do you think the next 10 years looks like for this space?
I could say in the very short term that we'll be having methane breeding values soon. At least research breeding values, they're just beyond the horizon. Like we can see them coming. Longer term, I can see that we'll have proxies for methane measurement. So as we already discussed, measuring methane is the hardest part. Phenotyping animals is so expensive and time consuming that we'll probably have things like rumen samples for microbiome populations, or volatile fatty acid profiles, even things like collars that measure rumination time and things. All these things will probably contribute to a proxy for methane. So I see that coming as well, but that's probably a little bit longer term, and we can probably see that more animals will have those measurements, and we focus more on measuring in the reference population these harder to record, more accurate methane measures.
Oh, that's so exciting. I can't wait to see all of this evolve. So I had another little question just off the back of that, but will producers be expected to measure their own methane phenotypes, or is that something that might happen through the reference population? Like, how's that going to work for them to get breeding values for their own animals?
I would say that it won't be expected for farmers to measure their own methane. I'm not saying that they can't or that they couldn't pay for that service. At the moment, I would say that it's more beneficial to measure on the referent populations. And I can't say what the future holds on that side of things, but I could definitely see that we are going to measure more and more on commercial properties. That's already happening within the sheep project as well. So
awesome. It sounds like things are moving along so quickly, and it's such a fast evolving space that a lot of people are looking on with interest. So I'm personally excited to see how things progress, and be exciting to have some breeding values for our ruminants to be able to start making some changes. Awesome.
It's a very exciting time and space to be in, absolutely.
Yeah. So we spoke a lot about methane in this episode, but you mentioned a fair few other factors within the sustainability kind of grouping. So what about those? Yeah.
I would say that they're coming as well, or some parts are already here. So like the feed efficiency, feed intake side of things, that's also sustainability, that, the grass should be used for production. But there's other things as well that we can start thinking about. So health and welfare traits around conformation and fit for purpose animals that have less animal health or welfare risks. So, tick resistance and heat tolerance, especially if the climate's going to keep getting warmer, having animals that are suited or can adapt to those higher temperatures and heat waves and things, we can start looking at those sorts of traits now as well.
Well, thanks so much for today, Michael. It's been really great to sit down and chat with you about sustainability. It's definitely been something that's popped up in a fair few episodes, so it's nice to sit down and basically have a big deep dive, and especially with somebody who's had a fair bit of work and experience in there. So thank you so much. It's been a great episode.
No, thank you so much for having me, Emily. Really enjoyed it.
Thank you. And that brings us to the end of this episode of Genetics in the Paddock with Emily. I hope you found our discussion as enlightening as I did. This episode was produced by the extensive livestock genetics team within the New South Wales Government. If you enjoyed this episode, please consider subscribing to our podcast on your favourite platform, leaving us a review and sharing it with your friends and colleagues. Your feedback and support help us grow and reach more people who are passionate about livestock genetics. If you have any questions, comments, or suggestions for future topics or people you'd like to hear on the show, please feel free to reach out to me on emily.johnston@dpi.newsouthwales.gov.au. Thanks again for listening, and until next time.